perfect thing to talk about. Okay, so I'm recording now. So we're getting ready for the final project and the final exam, right? We're getting close to
Mm-hmm.
the end here. So the final project, lots of people are asking very, very good questions, very relevant things to them. They're looking for good data sets. So Courtney, you're looking at unemployment rate nationally compared to Story County, right?
No, it's just Iowa compared to
Oh,
Story
just
County.
Iowa and Story County. So the
Yep.
unemployment rate. So the great thing is you pretty easily found the unemployment rate for Iowa. You can even point it a day and time or current or whatever, right?
Mm-hmm.
So that's a perfect say. So you're like your null hypothesis then is P equals whatever that percentage is, that rate.
Yep.
So really all you're going to be doing is taking Story County as your quote unquote sample compared to this population proportion. So did you find a good website that shows unemployment statistics for county by county?
Yeah, I found the Iowa Workforce Development page and it was really good. It showed me specifics on every single county in Iowa and all the numbers that I needed.
Cool. Um, and so what's interesting with questions like this is if you're since you've got this data now, do they know exactly what the unemployment rate is? No, it's always an estimate. There's guessing based on unemployment claims and all these stuff, but it's probably pretty close. It's kind of like the census. We don't know exactly how many people live in the United States, but we're doing our best trying to count everybody. And that's where stats is. There's always, but the good thing is this labor statistics stuff you're looking at is usually pretty close, and the data that they're reflecting is essentially how many unemployed people have filed for unemployment compared to how many workers there are, and you get that percentage. I think that's pretty much what it comes down to, right?
Yeah, I believe that's how it ended
Okay,
up.
so like how many workers are there in Story County? Is that on there?
Yeah, it says 59,500.
Okay, and how many are unemployed?
1,700.
All right, so there's your p hat, right?
Mm-hmm.
And then so now you're pretty much set up to do a one sample z-test for proportions.
Yeah.
Because when you're just analyzing proportions, uh, when you're trying to find the standard error or the denominator of that formula, it's based on the percentage and the sample size, which you have. What you're usually going to find is when you have huge numbers, like thousands of subjects in your sample, a very small difference will show very statistically significant difference, which is, I'm guessing, what you're going to find. You're probably going to find that Story County is statistically significantly lower than Iowa. Um, well, why do you think that is? There's lots of reasons. What do you think? Why is Story County probably way better as far as unemployment rate?
Well, where I live, there's a ton of farmers, so they
Hmm.
usually don't go unemployed because the farms weren't, I don't know if they were super affected by COVID,
Hmm.
and they just tried to keep everyone employed as much as they could. Like where I worked, they tried to make sure that I could stay as long as I could, and I did keep my
Okay.
job. Um,
And there are a lot of those are what we call self-employed kind of business owners, right? The farmer is. But
yeah,
what's going on in Story County? What's the big thing that's in Story County?
don't put me on the spot here. I don't
Well, I'm a
know.
big fan of their football team.
Oh, Iowa State.
Iowa State Cyclones, right? So the Cyclones
Yeah,
are there. That's Iowa State. So you got this very large land grant university with a bunch of highly educated people in town and a
yeah,
bunch of professors and a bunch of startups that hire a bunch of engineers. So you have Story County has probably even a disproportionate number of educated people. And in general, people that have degrees beyond a high school diploma, the unemployment rate is crazy low. Like if you get a bachelor's degree, the unemployment rate is usually half of the national unemployment rate. Associates is very low as well. So essentially, the more educated your population is, the lower the unemployment rate. Story County is actually, I think, known to be one of the national leaders and lowest unemployment rate in the United States. They get reported in the top 5 sometimes. I heard at one point before the COVID recession, I think they were under 2%, like 1% or something. I mean, like they're begging for people to work there, right? So it's some of the, I don't know, here in Grimes, where I live in Des Moines, there's a help wanted sign on everything, I think it feels like. But again, certain communities that have these types of groups. So here's the deal: you've got Story County, which is, very strong economy, very strong in education, very strong, very low unemployment. And then you've got Iowa, which is much more diverse. Some counties are going to be just like that, others are going to be worse. So that's why I'm pretty confident you're going to find Story County's statistically significantly lower unemployment rate. You'll be able to do your confidence interval. You'll be able to do your explanation. It'll be very straightforward. How's that sound?
Yeah, well, I already finished it all and it was pretty straightforward, like you said.
Okay, what was your Z-score? Do you remember?
Yeah, I actually have it pulled up right now. It was
I bet it's huge.
negative 22.17.
Yeah, that's big. So yeah, that's so that's like saying, what's the probability that you would get that difference by chance? And the answer is 0. It's not going to happen by chance. That's really what you're doing with stats, is you're trying to figure out, okay, here's what I think's going on. I'm going to test that. Here's what I found. Now, what's the probability that I would get that result, assuming the null hypothesis was true? Well, you're probably not gonna, if you're assuming that essentially Story County is the same as Iowa, you're going to reject that null hypothesis and say it's statistically significantly lower. Now, could you be wrong? The answer is yes, but the probability of you being wrong is super small. That's that p-value. The p-value describes essentially the probability that you would make a type 1 error, which means you would reject the null, in this case saying Story County has a lower unemployment rate. You reject the null and say, nope, it's lower, but you would be wrong. That would be a type 1 error. You're not going to probably make a type 1 error here, but that's what that p-value describes. It describes you the probability of this happening by random chance, which is also the probability that you don't make the correct conclusion, which you're not going to make the wrong correct conclusion. And then a type 2 error is if we would, fail to reject, but we should have. That'd be saying it's not lower in Story County, but it really is. So that's a type 2 error. So that'll help you kind of prep. Remember that on the last exam, the chapter 7 through 9 exam?
Yeah.
Yeah. So a lot of people, I probably emphasize that more than I should. Maybe, I mean, obviously you've got homework problems and it's part of the curriculum and everything, but I think I asked those questions because beyond this course, that type of thinking becomes more important, I think. Yeah, I think it does. But no, you picked a what I would call an atypical project that we get. Like it's a good, straightforward, normal, not crazy hard to find data. What's your major, Courtney?
I'm still in high school, but I plan to go into animal science next year.
Oh, very cool. So, with medical and science and animal science, there's tons of research all the time, right? And so they're trying to find what's the more. So you're obviously, I grew up on a farm too. So there's always agronomists and there's always animal scientists that are trying to figure out the most effective methods, right, to raise animals. Best production methods, lowest stress, most efficient. So they're always doing these kind of studies on that to say, okay, here's like they'll do a big test plot, right, of seed corn or with do you raise cattle or hogs? What are you into for animal science?
Oh, we have a herd of goats and a flock of chickens.
Okay, yeah, I had sheep growing up. So like they'd say, okay, for these goats, let's try this diet versus this diet, right? If you're going for milk production or health of their birthing or whatever. And so you can do these controlled studies and experiments and figure out and then there's always research journals coming out that. And then what's interesting is it's kind of like with humans, what's considered safe and effective. Same thing. By effective, that means, is it statistically significantly better than what we were doing? And obviously with production is, what's the cost to get that? And is it worth the cost benefit analysis of doing either that vaccination on that animal or that supplement or amping up the protein or whatever it is that you're looking at. So this statistical thinking becomes super important when it comes. So here is this 2014 one, this supplement to the final, will give you good content over the last 3 chapters. Honestly, this firm right here is just I'm gonna make this a little bigger. Hold on. Do you know how to make that bigger on your end too? Up in the upper left-hand corner, there's a little zoom feature.
Well, I have it pulled up on my computer, so it's.
Oh, okay.
I can read it all.
So obviously, I've just got one hypothesis test and confidence interval here, so you can kind of expect, obviously, writing out 1 or 2 of those, kind of like the chapter 7 through 9 test.
Okay.
But what you're probably most interested in is that chapter 10, like the residual plot. So here we go.
Yeah.
So here's an example. I give you some raw data. I give you the regression equation, and then I ask you some questions about it. So you're never going to have to find the regression equation. You're just going to have to analyze it. So the regression or residual plot is just a plot of how well do the data points fit the best fit line. So for instance, this is the line of best fit, right? This red line.
Mm-hmm.
Here, I'll get my pointer out. There we go. So this red line is the line of best fit. So all we're looking at is how do these blue dots in relation. So like this one's above. See that? It's above, 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 below. See how that? So really all we're doing is it breaks down this model, and we don't really care about the slope when we're looking at the residual. What we're looking at is if there's a pattern or not. If it's a good linear model, we should see really random here. We shouldn't be able to see this kind of has a pattern, doesn't it? We're above, then we're below, then we're above. So it may be more of what we'd say a nonlinear pattern. So a good residual plot shows a lot of randomness. Dots that are closer to the line are going to make the R value be stronger, the correlation coefficient. Notice this R value here was only like 0.35. A perfect positive correlation is 1. So anything, right? It depends on your sample size, and I know you've done a few homework problems on that. But and as a general rule of thumb, if you're not seeing like 0.7, 0.8, 0.9 as your R value, you're going to start saying, maybe this isn't a super strong correlation. That means the dots are kind of far away from the line. If it's a negative R value, that means the slope is just negative. Same thing, -1 is a perfect negative slope. All the dots would be on the line. So does that residual plot make sense to you, how we do that? Just make a horizontal line and then put the dots above or below based on what this looks like.
I think so. So you have like the 50, 100, -50, -100. How do I decide that? Is it just based on like how far away
Yeah,
the
like
dot
this
is from
one's
the
50
line?
above right here. So I just
Okay.
made that one about 50 above, and that's about the same. And like this one's like, 100 below. So I'm not going to get
Okay.
picky on how close you are. If you're using StatCrunch and you've got the raw data and you do there's a box to check that says make residual plot. It'll just do it for you. So I would, maybe practice and look at a few of those when you're doing your chapter 10 homework or going back and look at chapter 10. Just do that. And I think there is also a video on in the chapter 10 content over residual plots and how to do with StatCrunch.
Okay.
And then analyzing the R value, a lot of people mess this up. What does R squared tell us? So you square 0.3519, that's R squared is 0.12. That is the percent of variation that is explained by this variable. You're like, what the heck does that mean? That means, let's see here, reading speed, how fast people can read, it does seem to go up, right? If they're faster typers, it looks like they're faster readers, but it's not a super strong correlation. In fact, we can only say about 12% of the variation can be explained by typing. So the 12% of the variation in reading speed can be explained by typing speed. So it's not a very strong thing, because there's lots of variables that go into reading speed. We're only just looking at one. In stat courses, maybe down the road, if you get to multiple linear regression, you can look at many variables and see which ones are the most important or strongest. But we're just looking at one, how do these variables relate? The R squared just tells you the percent of variation that is explained by this independent variable. Cool?
Yep.
And then if you want to make a prediction, what's the line predict the value to be? You just plug the number in for X, right? That's pretty much how you get that. So the final will have some scatter plots. It may ask you to draw a line of best fit, or look at some data and say which one's the strongest or weakest correlation, which one looks like a linear model would or would not be appropriate, make a residual plot. Those types of questions could be on the final. So I would, just if you go through the supplemental stuff and watch the videos over those on Blackboard, you should be good to get all the, chapter 10, 11, 12 stuff that's on the final.
Okay.
Do you want to look at this last page while we're here?
Sure.
Yeah, this is a goodness of fit test, chi-squared. I think we're just analyzing see if a die is fair. So our null hypothesis is that it's a uniform model, that they're all going to be the same. Like you roll a die, they're all supposed to come up the same amount of times. We know in reality that doesn't happen, but the question is, when we do that, do we experience something that would show statistically significant difference from that model? So if you add up all these frequencies and divide by 6, you get 8. So we should experience 8 1s, 8 2s, 8 3s, 8 4s, 8 5s, and 8 6s, but that's not what happened, is it? So we can do this chi-squared analysis. You can do this in StatCrunch, or just, it's not that crazy hard to do by hand. 13 minus 8 is 5 squared, 25, so it'd be 25 eighths. And so you just do that, and it'd be 49 eighths, and you add all those up, and you get this chi-squared statistic of 22.25. Look that up on your chi-squared calculator, or you can use the table, but I just go to StatCrunch, use the chi-squared calculator. Let's see here, there's 6, so it'd be 5 degrees of freedom. Type in 22.25, you're going to get a really small p-value. If you use your table, it's going to be under 0.05, because that's all the more it goes. You're going to reject the null and say this is not a fair. We have statistically, we have enough evidence to say this die is loaded. Something's wrong with it. Obviously, you can test it more and check it, but the probability that we would get this distribution if it was a fair die is super small, which tells me it's probably not a fair die. How's that sound?
Sounds good.
All right. And the last one is just analyzing a p-value here. So this is the cool thing. From this course, you're already going to, like, I was working with some other student today. They found some really cool research on how well people work and different factors that cause them to maybe not be as productive. Things like, like what they call it, cyber sloughing or something like that, getting on their phone or surfing the internet, or people bothering them, or just kind of procrastination things, or what things actually help them. If they have like, oh, this is meaningful work, or this is, and it was a really advanced multivariable analysis with a really complex regression model. But what's cool is, even if something is super complex and you have no clue how they're getting stuff, you have the ability to take this p-value and start thinking like, okay, what's going on here? Now, the problem with this problem is there's no context, so this is a bad problem. And this is not one on the final. But the one on the final is more like, hey, we've got all these different groups, or all these different populations. Let's say it's houses in different towns around Des Moines. We have this mean and standard deviation, the average and the standard deviation of all these houses. Our null hypothesis is that, let's say, Grimes, Ankeny, Johnston, and Altoona are all the same, right? The means would be equal. The alternative is that they wouldn't be equal. Well, if I told you that we did this analysis with all these means to see if there's at least one that was different, and we got a p-value of 0.01, you'd be like, well, that tells me at least one of those cities has different valued homes. That's it. So even if you don't understand the study, but if you can think of the context and the question and you look at a p-value, you can say, oh, there was statistically significant evidence that reject the null. And what's that look like? So that's what that last question is asking, is to take a situation and just say, okay, here's the p-value. What would that mean? Which going forward in your life will become very valuable. Like you will get some animal science research. You'll look at it, you say, oh, they studied this feed additive, blah, 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 here's the control, blah, 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 and they showed this much difference in weight gain, and the probability of that happening random chance, p-value less than 0.001. You're like, whoa, that's really strong evidence that helped. You don't even have to really analyze the method too hard. You can take that p-value, look at how they did it, and then infer the result from there, which is pretty awesome, actually. So doctors do this, nurses, anybody. I think we're inundated with research studies anymore, which is why pretty much stats is required for every major anymore, because every discipline pretty much uses it. So is that helpful?
Yeah.
I just gave you a little mini lecture there about stuff. But,
That's fine.
Yeah, so I some people have emailed me a little freaked out about the final. I'm like, you know what? Study your first 3 exams, and I'm going to be. I had a scenario with COVID in one student, so I'm still delaying releasing that one. But I think I'm going to have to release it by tomorrow, because, well, before Wednesday anyway, because Wednesday is the first day people are supposed to start studying for the final, right? Because they've got until the next. But anyway, if you study the first 3 exams, solutions videos, understand that content, go through these supplements that are in the review folder, take a look at these old exams, go through that, regression, goodness of fit, little ANOVA stuff, you're going to be just fine.
Okay.
And so the final exam is worth 50% of your final exam grade, and your project is worth the other 50% of your final exam grade. Those things combined are 25% of the total course grade. So if you think about it, they're each worth about 12.5% of your overall grade. Your other exams were each worth 15% each. So actually this final exam is worth less than each of the other 3 exams, if you think of it in the big picture.
Okay.
So hopefully that makes you feel a little better about it. Plus, most people do very good in their projects. You're going to do great. I mean, you already told me. So you're probably going to get an A on that part already. So no worries, right?
Mm-hmm. So,
you're doing great. You're doing great.
do you know how many questions are going to be on the exam, or can you tell me that?
If you look at, there's about 15. It's only going to take you the same amount of time as a regular test.
Okay.
It's the same time limit. It's 2 hours. So it's not going to take you any longer than any of the exams you've taken. So I've really pared down what's on it. There's not that many questions. So there's not it's not a long exam, because you only got 2 hours. So that's why I'm only going to ask you like 1 or 2 questions about chapters 7 through 9. I can only ask you 1 or 2 questions, like 2 or 3 questions about 10 through 12. I can only ask you a few questions from 4 through 6, So I can really only ask you about, a dozen questions total to get that. But obviously I make questions that are open-ended and multi-part, but I do highly encourage you to show your work. Really, that's important. Like, you do this now, 95% confidence interval. The problem is if somebody just writes down the wrong answer here for the confidence interval, I give them 0 out of 3 points, right? That's bad. But if they wrote down like this formula, or even the formula with the numbers in it, and they just made a little error, I could, like, if somebody wrote this down right here and totally miscalculated the confidence interval, I'd still probably give them full credit. Because I'm like, oh, they know what scenario is, they know what the numbers are, they actually found the right t-value here. But it's fine if you use StatCrunch and I just did it, and here's the 95% confidence interval. I would encourage you to at least write that formula down if you want to make sure you get partial credit, because if you made a mistake, I can't give you any credit. Same thing up here, right? The this T statistic. If somebody gets this wrong and gets this wrong, it's worth 2 points, but I could give them 1 point if they actually had the right test picked out from the formula sheet. So that's why I encourage just showing that work and to kind of guard against that. It's totally up to people, but I hate it when I'm grading them and I'm like, oh, they really screwed that up. And I can't give them any partial credit either. That pains me. I'm like, I have a feeling they know which test they did and they might have done something wrong, but I don't know because there's nothing in the exam that I can grade. So I encourage you to show work. How's that sound?
Sounds good.
All right. Well, thanks for letting me talk to another human being.
Yeah.
And that's I miss that sometimes. I think my wife's ready for me to talk to somebody else too. We've been married for 25 years, and she's awesome. But anyway, we got COVID out of our house now, so we're feeling pretty good.
That's good.
It is good. All right. Other questions you might have about the final project, the final exam? Are you feeling a little better about it?
Yeah. I've been doing pretty good on my tests, so I figure if I just go through some of those,
Yeah, you'll be golden. If you've been doing well on the exams, yeah, a quick review of those, you'll be fine. And then just studying these last 3 chapters and looking at these supplements, you'll be ready to go. And like you said, you're gonna take the test, the final on Friday. Yeah, you'll be. Well, you'll probably submit your project before that, right? And you
yeah, I already
will.
submitted it.
So yeah, so
So.
good. I can actually go out and grade it. And, so you'll be done with the course on Friday.
Yeah.
Now, if you don't get the grade you want on your final project, there's something weird or whatever, I'll put comments in there, and you can resubmit to improve it. Okay.